Hi guys, this is Ashwin and we are building SuiVerify and what is SuiVerify and why we need it. So we are building a decentralized identity layer to replace the centralized identity related products which exist right now. So that is a major problem that we see and we are keen to solve that. So what is the products, like what are the components that powers SuiVerify is? We use Nautilus, Seal, Walrus and the SDK that we built and zk login and passkeys. So why Nautilus here? So basically we use Nautilus for the off-chain computation and making it verifiable on-chain, right? So the government documents provided by the user is verified in Nautilus, and we attach the documents related to the verified document on-chain, and these are not sensitive data, and we also use seal for the encryption process of the government document that we process inside Nautilus. Since we are just processing, we don't need to hold the exact document in the centralized services. We are processing it with seal and then storing it in the Walrus. So why we do this is basically to have the compliance between the SuiVerify and the government, and also we as SuiVerify won't can't access the data which is stored in the Walrus. So the whole document itself is only like usable by the user, and he gives the access to the entities that he needs for the future complaints with the ID that we provide. So this is the whole thought process of building this, and SuiVerify SDK is nothing but which glues the exact total infrastructure together. So whatever off-chain computation that we do, we attest some on-chain proofs using enclave contracts, right? So what we do is we use SDK, SuiVerify SDK we built. This SDK will be integrated by the protocols, and so that the DID that we issue will be given to the protocol, so that the protocol will verify it using the SDK that we provide them. So zk login and passkeys are for the seamless UI and UX for the user, and we have also integrated key gas sponsorship over here. So what is the architecture that we have built? Currently what we have. So this is the total architecture that we have built right now. So whatever this is the front end pages basically, and this is the Nautilus infrastructure, and we have a Sui indexer to index every data on chain, to have a separate explorer to see who are decrypting the document. Decrypting the documents is obviously it will be decrypted only by the government entities, and as well as the verified entities by the user itself based on the access policy that they define using the seal seal protocol. And yeah, so this is the whole process, and whole architecture that we have built, and we will just discuss and show how this exact whole architecture comes together in picture. So let's get into the demo that we have built. It's more like we are building actually. So it's been months working on SuiVerify, and we are just upgrading over and over. So this is our version 2 or the MVP that we built previously. So this is our landing page basically. Still we are working on it, and so basically when the web 2 and web 3 users comes here, they can see whatever process that we did, and how we safely give them the DID for the users, right? Like this is our landing page giving every details, and to view the SDK documentation, we have integrated everything in the landing page. So this is the latest SDK update that we did 4 days ago, and yeah, so yeah, let's get into the DID issuance part, and we will continue exploring about SuiVerify. So this is our DID issuance dashboard. So the actual flow would be user goes to a protocol, and protocol would have already integrated our KYC infra, right? So the user will redirect to the dashboard, and they will do the KYC process, and using any government issued document that they have, and after they do that, they get a DID, and using the DID they can verify themselves in every ecosystem where the SuiVerify infra is integrated. So this is the base idea that we have, and also we are live in this exact domain as well. So we are just showing it. So this is the exact small DIDs that right now it's available, but we have the real-time verification with regards to the PAN card issued by the Indian government. And so when you do that process, we just need to have some more components added in the front end, where it is like it is when you verify a pan card, you get avail of different IDs related to financial institutions that you can financial platforms that you can access, take exchanges, or take loan giving platforms. You just verify yourself, and you can get the credit scores over there with the DID saying that you are available to get the loan. So that is the whole process of verifying the government documents that we are essentially doing, right? So the whole process is like, user just signs in with his Google account, and after he signs his with Google account, he gets wallet under the hood using zk login, and next up what we have is, we have also integrated Enoki gas sponsorship. So what it does is, since there is only seamless effort for the user to gain an DAD, we are sponsoring the gas regarding to that. So yeah, we are just starting the verification using a pan card document basically right now. And we have these this is the future process that we need to do, or expanding further, government by government. And right now, I'm just giving a pan card. As you can see, when you verify with pan card, you get access to tax ID verification, like age verification, income tax compliance. So based on the ID that you give to the SuiVerify infra, you avail a different DID, right? Like so bunch of DIDs. So with the DIDs, you can access different platforms. So that is whole point of verifying the government document here. So I'm just uploading my pan card. So after you upload the pan card, as you can, it's the same process. This the centralized KYC services, but we are doing in the decentralized infra, and availing the reusage of the government documents without giving the government documents itself, using Nautilus off-chain computation here. So so this is the next process would be like face verification. After the face verification, you just go to next steps. So next up is the actual, we send the details to the enclave to process, and the enclave basically access the government repositories and do the verification process. And yeah, let's proceed with that. So after the process is done, the document will be encrypted in the client side and processed to the Walrus publisher and aggregator. Like Walrus publisher, and we use the aggregator to basically aggregate the blobs. That is a different area where we showcase the decryption process of the platform. We will show that. And yeah, after the encryption process, we show the encrypted document blob to the basically to Walrus. And let's just this is the DAD NFT is nothing but our soulbound NFT after the NFT after the claim process is done. So like after the issuance process is done. So when you just claim the NFT, there will be like seamless user experience for the user, for the Web2 users. This is this is the sole thing here. We have integrated Enoki gas sponsorship, right? So under the hood, and also zk login. So which this makes the verification seamless. So this is just the we need to change the logos here. But yeah, let's start seeing the fields over here. So as you can see, we have multiple fields involved. So this is the main part of attesting the metadata in the NFT. So why we do this is for the future compliance with other protocols that integrates SuiVerify, right? So the SDK use these metadata to verify the NFT provided by the enclave itself. So signature, timestamp, evidence hash. So evidence hash is the payload of the exact document processed. So yeah, these are the payloads that metadata that we attach to the NFT, like soulbound NFT. That is the DAD in our thing. And yeah, this is the actual issuance process. After issuance process, you can see whatever credentials that you have received, everything. So yeah, let's jump on to the verification process. So I am going to reuse this digital identity that I have got myself in other protocol which integrated SuiVerify SDK which we have built. So let's see that. So I just also want to show the process SuiScan as well over here. So basically, all these are the registry DAD registry contract that we have. So for the on-chain attestations that we do, for the off-chain computation that we do, in the inside the Nautilus enclave. So this is the contract that is involved package. So yeah, we will attach everything in the repository file as well. So yeah, let's get into the SuiVerify SDK integration part and how it is integrated and how the DAD re-verification is done. And yeah, let's further continue. So before jumping into the DAD reusage, we will just see our dashboard itself right now. So why I'm showcasing this is we have a payment module, and we use that basically we use that payment module to make settlements between SuiVerify and the protocol which integrates SuiVerify. Take it Web 2 application or Web 3 application. So if you take a Web 2 application, they don't actually involve with the wallet and stuffs, with blockchain stuffs, right? So what we do is we can have the payment coming to us directly, and we can do the funding of their vault in the payment module that we designed, so that for every DAD re-verification or whatever first issuance as well, the settlements can be done via that vault, which stores the assets inside. So that is the whole point here. So I'm just connecting my wallet here in our admin dashboard. So this is like a simple front end that we have, which which is integrated with our payment module, and it is it's based on the dollar that we charge, like dollar in the sense, like according to our business model, it's going to be around 1.25 1.25 to 1.15 1.15 to 1.25 dollars for every verification process that we do for the protocol itself. So we register the protocol name and whatever details that we want with regards to the protocol registration. This is basically, and then we fund the exact vault, and after funding we just basically start with the protocol, and SuiVerify is already integrated, right? So so this process actually happens after the protocol itself integrates the SDK also. So yeah, let's talk about the DAD verification right now. So let's start with the the DAD reusage part. Reusage in the sense, like you as a user, I got a DAD from SuiVerify, and I want to use that instead of doing a KYC process. I am giving the document which is not secure to the centralized services out there. So what I do is, like, you can see the address over here, and yeah, connected with the same, like. So what we will be doing is, as a SuiVerify, like from the SuiVerify team, we give a component to the team which integrates SuiVerify itself in their dashboard, basically for the centralized for the KYC process that they ought to do for the user, right? So when it comes down to that, so they basically integrate our dashboard, and after the dashboard is integrated, so the user connects with their zk login wallet which they have used in the issuance process, and they just click just verify themselves, verify their NFT, verify the soulbound NFT that we have provided them, and they just give verify this verify my NFT, and yeah. So this protocol we have registered in the dashboard that we have previously shown. Its name is test, and the settlement fee associated with the protocol paying us is going to be around 0.03 SPI right now. So it will be around the payment revenue model that we discussed, right? So when I just click confirm and verify, it will just discover the NFT type that is in my wallet, and after that is done, it will do a on-chain verification with the enclave that is registered on-chain enclave object. it will see whether that exact enclave gave this DAD NFT or not. So this process will be done using the SDK that we have integrated. So SuiVerify SDK is integrated in this exact process. So that is the process that we do. And after it is done, the settlement is also will be done. So after for every DAD verification is being done, we consume from the vault, like the SuiVerify vault gets the amount paid from the protocol itself. So and we have an explorer for that to view, for the protocol to view the transactions being on chain, happening on chain in our explorer also, because since we are also focusing on the Web2 users, right? So yeah, so continue to SuiFlix. Basically, we are just diverted into the access granted. So this is the simple basic front end that we designed with the SDK that we have designed. I'll just show you the NPM. Yeah, here it is. So this is the SDK that we built, and this SDK is recently updated and also integrated with the front end SuiFlix component that I have shown you. Let's get into the decryption process right now. So yeah, before that I also want to show the demo of the explorer that we have built. So this explorer basically acts as the transparent system for us, basically, because we are integrating Web2 protocols as well, right? So the Web2 protocols needs the easy usage of seeing whether how much settlements is being happened for the exact DAD that is being verified. So everything it should be transparent. So as you can see, these are the SBT claim as being happening, like the claim that we did. So it's just our indexer is started right now. So as you can see, it will just increase from checkpoint to checkpoint. It just goes to checkpoint and consumes every data, and with regards to the SBT claims happening in our module. And so it's like 41 days ago, 42 days ago. I can just also just get this SBT ID here, and SuiVerify just scan testnet transaction. Okay, it's going to be object. So yeah, I've just I'm just showing you the exact NFT that is being minted before 41 days. So our indexer is just polling every data from our module and just showing here, that is a process that is happening. And we also have real-time processing between the SSE and REST server that we have through a Redis server, Redis DB. And it acts as with the pub and sub mechanism. Basically, whenever data is coming through, it pushes to the SSE server, and SSE server pushes to the SBT claim here. I will attach the architecture as well. So this is the reusage that we did. So as you can see, this is the protocol name that we have registered. I have mentioned, right, the test protocol, and this is the user address and the payment transaction digest. So I'll just copy this digest and showcase it here for just transparency that we have integrated within the application. So this is the payment module that we have that the microservice called. So as you can see, around 0.03 SUI will be consumed from the protocol vault, and these are the transaction details that you can see. So let's get into the next process of the basic next process is complying with the government, how we do that, and as well as how the user can give access to separate entities with time-based process, within this time only the entity can decrypt and see my document and allow me for the next process. Everything we will see in the decryption process. So yeah, this is the explorer that we have built right now. We need to upgrade a lot here. Yeah, let's get into the decryption process. So how the decryption process is going to look like, and more like a decryption, how we are going to comply with the government, right? So that is the process that we will see right now. So this is our this will be more secure. We'll give access to only the users of SuiVerify, and also the government entities which is going to come into the picture when there is a complaints need occurs in future. Say I issue a DID to a user, and it is there is a problem with that user for the government. The government should verify the document. He comes to the why he needs to verify is when it's a digital crime happening, take in that fashion. So when it comes down to that, as a DID issuer ourselves, we should comply with the government, right? So that is a process here, because the document itself issued by the government, so there is no problem here. And when it then the control itself relies on the access control policies that we define. It will the allowance will be given to the government entities and the entities which the user allows. That is the next process that we'll see. So this is the overview of our decryption history. So we'll make it public basically. So whatever documents is being decrypted by which entity, everything will be given in a separate explorer. So now what I'll do is I'll just connect my wallet. So what I have done is, so this exact address is whitelisted for decrypting the specific documents. So since assume this is the government address, and now what I'm going to do is take a blob ID, recent blob ID that we have just stored for the centralized KYC verification process, and okay, it's valid address. Okay, so I'm basically taking the owner's address, and the government just use fetch documents, and as you can see there is a JPEG arrived. So as you can see the view attestations view blob here, you can see the blob details and as well as the object details over here. Object is like the attestations that we do with regards to the blob storage at Walrus, right? So this is the blob as an encrypted blob basically, and as you can see 31 minutes before. So let's just decrypt this document. So the point of building this is with regards to the complaints that we need in the future for the re-verification process involved with regards to different protocols. And currently we are using public aggregators, so that is the point. That is a process that we do right now. We need to set up our own publisher and aggregator by setting up our own daemons in a separate server. So the overview component is basically where you just so this is my document that we gave, right? So just close it. So the whole point of building this exact decryption history part is in the future, when, as I talked about, we need to have the access control policies more flexible for the users, where he provides access to the government documents for verifying the DID that we have provided. So that is a point here. And let's discuss about the future for this exact infrastructure base layer that we have built. So let's get into the future of this exact infra that we built. So for the notice here, this is just the dummy data that we have provided here. But the indexer needs to poll every data one checkpoint by checkpoint. It is behind the checkpoint, so it is just taking some time. And I'll just show the architecture first of all to explain the process. As you can see, the whole process is we have shown as a demo over here. So this indexer basically indexes every checkpoints and gets the module related details that the process happens on chain, and post it to the DB. And currently DB we need to have a separate Kafka queue separately for just short retention period. So pub and sub mechanism is for just giving the real-time events to the front end via the SSE server slash REST server as well. So this is a REST server, and using Axiom framework, and this is going to be a Node.js microservice which listens for the events from SuiVerify SDK. So whatever verification happens, we have the settlement done in the module that we have designed with the payment module, and we update in the protocol dashboard via the indexer, right? So currently we update it via the the server itself. Yeah. So this is the whole process, and what is the future of this exact base layer that we have built. So let me just, here it is. So when we talk about moving this forward with with different broad categories of issuing issuing DIDs, we are verifying different documents, and we just cover with a certain region right now, and then we move to different regions. And SuiVerify cKYC is the next thing that we are looking ahead, where the the encrypted metadata that we will be having securely in the address will be given, that is not something like a privacy data of the user. So it's going to be just the metadata, whether this user is issued KYC verified or not, and such related identity related metadatas will be stored as a centralized, more like a SuiVerify KYC repository and ID related repository, where the entities, like they don't need the DIDs itself, they just need the metadata, they can access them, and in a secure fashion, the whole process of that is like we have the process, we have the base layer built, right? We can do this as well with regards to the future that we talk about. So this is the whole process that we have built. Yeah, thank you. We are also live with the exact process that we built, except this component we need to make it live, the dashboard and the dashboard component, basically dashboard in the sense dashboard component, and as well as the explorer component, we need to make it live. Live with, yeah, thank you. We the repositories and contracts involved, everything we will attach in the video. Thank you.